Hello, we are back again with your favorite teacher, your very favorite subject, Algebra 1. We are using Bob Jones University Press Algebra 1, the second edition, and this week we are working with solving quadratic equations. Before I begin, why did the chicken cross the egg? Why did the chicken cross the egg? No. Why did the chicken cross the road? Well, the chicken crossed the road to get some exercise, of course. So, I'm thinking that y'all really need to come to my aid here. These lame jokes are getting worse and worse and worse. We are on section 11.6, 11.2, solving quadratic equations by factoring. Let me read just a little bit. Page 446, you can solve many quadratic equations by factoring. However, always be sure to remember that and make certain that the equation is in the general form first. We have their little list of things to do on page 447. Arrange all terms on one side of the equation in descending powers of the variable set equal to 0. Factor the polynomial side of the equation. Set each factor that contains a variable equal to 0 using the zero product property. Solve the equations. Check the solutions in your original equation. And this is something that you're going to really learn to do almost without thinking. It's very automatic. If you look at this set of rules, set of your description here of what you need to do, it can be confusing, but it really isn't. Remember what your zero product property is. It says that whenever you have two factors or three factors or any number of factors multiplied together, if their solution is 0, at least one of those factors has to be equal to 0. There's no other way that you can multiply two numbers together and end up with a product with the result of that multiplication being 0 than if one of those factors at least is equal to 0. So because of the fact that when you have more than one factor multiplied together equal to 0, this is what they call the zero product property. And this zero product property helps us a whole lot when we solve quadratic equations, because this tells us that if we have our quadratic equation, and a quadratic equation, remember, is a second degree equation, that means that one of the variables is squared. The general form of a quadratic equation is ax squared plus by plus c is equal to 0. This is the general form of a quadratic equation. And it's very, very important that the general form of a quadratic has all of the variables and all of the constant terms over here on the left, and it only has 0 on the right, because when we have an equation set equal to 0, especially when it's a quadratic, and we're able to break that quadratic equation apart into a set of factors that are set equal to 0, then we're able to use this principle here that tells us that our product is going to be 0. As long as one of our factors is 0, then we set each one of these factors individually equal to 0, and we come up with the solution to our problem. So using our zero product property, remembering to put our quadratic equation into the general form where all of the variables, all of the constant terms are on one side of the equation, 0 is on the other side of the equation. That's what's going to make it so that we can very easily, very handily solve these quadratic equations. So let's just go ahead and do the first example for section 11.2. And let me get my book here. And this says, solve x squared plus 2x minus 63 minus 63 is equal to 0. This is example number 1. And it says solve. Remember, last section I told you that very quickly we would go to the point where they asked us to take a quadratic equation and break that apart into factored form. So when you have a trinomial, ax squared bx plus c equal to 0, that's going to factor into the product of two binomials. You remember how to factor. Our first term multiplied together has to equal x times x is x squared. Now we're going to look for two factors of 63. So when we multiply them together, we get the negative 63. When we add them together, we get a positive 2. Well, 7 times 9 is 63, right? You see that there's a difference of 2 between these two factors. So if we want to have a positive 2 when we add them, and a negative 63 when we multiply them, what are we going to do? Well, sure. It's going to be 7 plus a negative 9. I was trying to write the answer here. 7 plus a negative 9 is a negative 2. Is that right? No. Has to be negative 7 plus 9 to give us the positive 2, which is coefficient of our x term. Negative 7 times 9 gives us the negative 63. So we have x minus 7, x plus 9. There's my eraser. Let's check this and make sure. X squared plus 9x minus 7x gives us 2x. Negative 7 times 9 is negative 63. So this is the correct factored form of x squared plus 2x minus 63. Now, because on the left-hand side of this equation we have only factors, on the right-hand side of the equation we have 0, we use our zero product property that allows us to say that either x minus 7 is equal to 0 or x plus 9 is equal to 0. We solve both of these equations and we find that x is equal to 7 or x is equal to a minus 9. Now before we know for sure that these are solutions, we have to check these in the original factored form here. 7 minus 7 gives us a factor of 0. Negative 9 plus 9 gives us a factor of 0. So if we did our factoring correctly, we're all right. But let's go ahead and check that back in the original equation. So if x is 7, then we have 7 squared plus 2 times 7 minus 63. Is that equal to 0? 49 plus 14 minus 63. That's 63 minus 63. So of course, that's equal to 0. So this one works. What happens if we have negative 9 though? Well, negative 9 in parentheses squared, because you're not squaring 9, you're squaring negative 9 plus 2 times negative 9 minus 63. Is that equal to 0? What's negative 9 squared? Right. 81 plus a negative 18 minus 63. Is that equal to 0? 81 minus 18 63 minus 63 is equal to 0. So 7 and negative 9 both are solutions of this quadratic equation. And they'll frequently show the solution in set notation. Just means that you have this in braces. The solution set to the quadratic equation x squared plus 2x minus 63 equals 0 is a set that contains the elements negative 9 and 7. And you want to put the solutions in your solution set in order from left to right, going from smallest to greatest. That's all that's involved in solving quadratic equations. Now let's solve this one. X squared minus 49 is equal to 0. What are we going to do with this? We have x squared minus 49 is equal to 0. Okay? Two different ways that you can solve this one, but because we're using the zero product property where we have factors equal to 0, what do you recognize about this? Here's your little hint here. That's right, this is the difference of two squares. X squared minus 7 squared. So the factored form of the difference of two squares is a plus b plus a minus b, which in this particular case is x plus 7, x minus 7 is equal to 0. Continue on, you set each factor equal to 0. X minus 7 is equal to 0. X is equal to negative 7. Or x is equal to a positive 7. Do these both work in the original equation? Yeah. 7 squared is 49, minus 49 is 0, and negative 7 squared is 49, minus 49 is 0. So the solution to example number 2 is the set containing negative 7 and positive 7. See, these are so not anything at all to be afraid of. Let's see what we want to do next. We're going to go ahead and turn to page 448 in our book. And we have this example, 2x squared equals 7x plus 4. 2x squared equals 7x plus 24. Let me check and make sure. 2x squared equals 7x plus 4. And the answer is give the solution set to this equation. Okay? We know it's a quadratic because it has a second degree term here. Now, what do we have to do to be able to solve this? We have to be able to factor it. In order to be able to factor it, we're going to have everything equal to 0. Minus 7x minus 4 is equal to 7x plus 4 minus 7x minus 4. We had a 7x and a 4 on the right-hand side of the equation. We subtract 7x and we subtract a 4. The equation's out of balance towards the right. So we subtract 7x and we subtract 4 from both sides of the equation. You have 2x squared minus 7x minus 4 is equal to 0. Now what you need to do is, you have this equation, it's quadratic, it's in general form, where the whole equation itself is set equal to 0. We want to go ahead and factor it into two binomial factors. Our two factors have to be such that when you add them together, you get a positive 7. Subtract them, add them together, you get a negative 7. Multiply them together, you get a negative 4. So we know one of these first terms is an x and one is a 2x. 2x times x is x squared. The only way that we're going to get a negative 7, we have factors of 4 would be 1 times 4 and 2 times 2. It's going to have to be 4 and 1 because our outside term here, our outside partial product, when we say 2x times 4, that's where we get the 8. Or in this case, we have our negative 8. 2x times negative 4 is negative 8. We only need 7, so this is a plus 1. 2x squared minus 8x plus 1x gives me negative 7x. 1 times a negative 4 is a negative 4. The next step that you have, 2x plus 1 equals 0, or x minus 4 is equal to 0. Subtract a 1 from both sides of the equation, you have 2x is equal to minus 1. Divide both sides of the equation by 2. X is equal to a negative 1/2. When we have our solution to this second equation over here, x minus 4 is equal to 0, we have x is equal to 4. We have two possible solutions now to this quadratic equation. We have negative 1/2 and we have x is equal to 4. So how are we going to see if these values are correct? Well, you substitute it into the original equation. I'm going to go ahead and erase my work here. I'm going to write my proposed solution set. X is equal to minus 1/4, minus 1/2, and 4. This is what we want to check as possible solutions to this original equation. So we have 2 times a negative 1/2 squared. Is that equal to 7 times a negative 1/2 plus 4? First, you have to square the negative 1/2. That becomes 2 times 1/4. You say, how in the world is that true? Negative 1/2 times negative 1/2. Negative 1 times negative 1 is 1, 2 times 2 is 4. Or you realize that you're squaring the numerator and the denominator. 1 squared is 1, 2 squared is 4. When you have the negative squared, it becomes positive. Is that equal to negative 7/2 plus 4? Well, do you see that this is true? Well, let's see. 2/4. Is that equal to negative 7/2 plus 2/4 or 1/2. Let me write it this way. 1/2. Is that equal to a negative 7/2 plus 4? How do you write 4 as an expression over 2? Well, that's 8/2. Negative 7 plus 8 is 1/2. So even though what I have here says 1/2 is equal to 1/2, solution is negative 1/2 because that's the value that we plugged in for the variable. So yes, our first solution works. Now let's try that second solution. 2 times 4 squared. Is that equal to 7 times 4 plus 4? What's 4 squared? right at 16. Is that equal to 28 plus 4? Yes. 32 is equal to 32. So both of those solutions that we arrived at are solutions to the quadratic expression 2x squared is equal to 7x plus 4. We haven't come up with any extraneous solutions just yet. Let's continue with example 4. This is a real-life problem that we have here. Find the dimensions of a rectangular room 5 feet longer than wide, which requires 204 square feet of carpet. So we have a rectangular room that is 5 feet longer than it is wide. So if we have our width is x and our length is 5 feet longer than the width, it would be the width plus 5 feet. And what other piece of information do we have? Well, we have that the area of the room is 204 square feet. It's 204 square feet to cover the entire floor. You know that it's area because it's square feet. How do you find area of a rectangle? You should not even have to think about it. Area of a rectangle is length times width, or width times length. So you have x times x plus 5 is equal to 204. If I didn't want to do the sketch, I can say let w equal the width, or let x equal the width, then let x plus 5 equal the length. And when you do that, you have the width times the length is equal to 204. Now you have x squared plus 5x is equal to 204. Can you solve this problem yet? No, you can't because it's not in general form yet. You have to have this x squared plus 5x minus 204 is equal to 0. How in the world are we going to come up with two factors of 204 that are differing by only 5? This is sort of trial and error, but it's also the more familiar you are with how numbers multiply together, the easier off you're going to be. Okay, I see that I can divide this by 3 because 6 is divisible by 3. It's also divisible by 4 because the last two digits to get last two numbers together, the 0, 4 is divisible by 4. So let's see what happens if I divide it by 4. Well, that's 4 times 51. Is that helping us? Not a bit. Okay. 4, 6, 12. At this point, I think I want to prime factor and see what I have. I have 204. 4 times 51. 51 is 3 times 17. Aha! Right now, I have 17 times 3 times 4 is 12. It's not completely prime factored because 3 and 17 are prime. 4, of course, factors into 2 times 2. But if I have 17 as one of my factors, the product of these remaining factors here has to be the other factor. 12 and 17 differ by 5. This is what we need. our 17 is going to be negative. I'm sorry, our 12 is going to be negative because we need a positive 5 and a negative 204. So we have x plus 17 times x minus 12 is equal to 0. Can you see that? Multiply the first terms together, you get x squared. The outside product, x times negative 12 is negative 12x, plus 17x gives us 5x. 12 times 17 is negative 12 times 17 is a negative 204. So you solve this, and this tells us x is equal to negative 17, x is equal to 12. Now, the way that we have been working with these is you get two different solutions, plug them back into the original equation, and see if this is what you're looking for. Okay, well, can we just go ahead and do that? Should we just go ahead and plug negative 17 in? Well, you really don't need to. I don't know about you, but I have never seen the dimensions of a room be negative number of feet. Negative 17 cannot be the solution to this problem because it's a real-life problem dealing with the area of a room, so that you can figure out how much the dimensions of it. So 12 is the only number that can possibly be what we're looking for. So here's our original equation. Let's substitute in and see what happens. 12 squared plus 5 squared, plus 5 times 12, is that equal to 204? 144 plus 60 is equal to 204. So your solution now is not simply that x is equal to 12, is it? It wants to know the dimensions of the room. So the length of room is 17 feet, and the width of the room is 12 feet. That is the solution to this word problem. It's not particularly difficult. Be able to sketch a picture, come up with the quadratic equation, factor it, and turn your thinking cap on that says, no way, no how, is the length of that room going to be a negative 17? So that is the solution to example number 4. Let's see. How about if I do just one more example for you? I would like to do, I think it's number 24. Let me finish getting this erased and see if that's exactly what I would like to do. Let's see, number 24. A farmer planted 168 tomato plants. If he had 2 more plants in a row than the number of rows, how many rows did he have? What in the world are we going to do here? Well, it sort of sounds like a rectangle. It also sort of sounds like me. It's about how many tomato plants I have that are still out there. He has, or she, 2 more plants in a row than the number of rows. Well, let's think what this can be. Let's see. There's 5 plants in a row. And there's 4 rows. How many tomatoes do I have? Well, it's just area, length times width. 4 times 5 is 20. So let's use that same principle as we are solving this problem. We have 2 more plants in a row than the number of rows. So let x equal number of rows and it was 2 more plants, let x plus 2 equal the number of plants per row. So we're just going to multiply these together. We have the number of rows is one dimension, the number of plants is another. X times x plus 2 is equal to the total number of tomato plants, 168. X squared plus 2x is equal to 168. What do we have to do? You have to have this in general form. X squared plus 2x minus 168 is equal to 0. General form means that you have everything placed on the left-hand side of the equation, so it's set equal to 0. Now we have to factor, and we're looking for factors of 168 that are only 2 apart. So I'm going to go ahead and factor again. 168 I know I can divide by 4. 4 goes into 16, 4, 2. Let's see, 42 is 6 times 7 is 42. Well, that doesn't look right to me. 24. 24 times 7, 8. But it is. Okay. No good collection of factors here because it has to differ by 2. This is 2 times 3. 3 times 7 times 2. Aha! Times 4. What if we went ahead and blocked off these 2 factors? What's 4 times 2? That's right. 4 times 2 is equal to 8. And what is 3 times 7? 3 times 7 is equal to 10. 4 times 2 is equal to 8. Okay. But that's not what we're looking for, is it? 12 and 14, because what I did was I said 4 times 2 is 8, which is true, but I said 7 plus 3 is 10. So that's not the combination that I need to have, so that when I multiply the factors together, I have a positive 2. When I multiply them together, I have a negative 168. When I add them, I get a positive 2. But let's say, 2 times 7 2 times 7 is 14. 3 times 4 is 12. Now that looks good. If I have 12 times, I have a negative 12 times a positive 14, that should give me a negative 168. If I have a negative 12 plus a positive 14, that gives me a positive 2. There's my negative 168. Here's my positive 2. You see that it takes some trial and error, factoring, playing around with your factors. 3 times 4, 2 times 7 is 14. And your mental process may be completely different than mine is, and that's okay. But what we've ended up finding here with our factorization is this. We're going to have x minus 12 as one factor. We're going to have x plus 14 as another factor set equal to 0. You already see that our possible choices are negative 14 and 12. We have our solution set. Well, how did I figure that out? I'm using my zero product property. A product set equal to 0. It's always going to be 0 if one of the factors is 0. X minus 12 is equal to 0, or x plus 12 is equal to 0. I'm going to add 12 to both sides of the equation. I said x plus 12, I mean x plus 14. X plus 14. X plus 14 is equal to 0. I subtract a 14 from both sides of the equation. Now, we're going to do this same thing and take the negative 12, the negative 14 and the 12 and substitute this to the original equation? No, because this is a word problem. Word problems are real life things. They have to make sense in real life. Can you have a negative number of rows in your garden? No, not unless the gopher comes along, eats all your plant, and then digs holes in a new row for you. So no, you cannot have a negative number of rows in a garden. So the answer has to be 12. Let's make sure that it works. You have 12 times 12 plus 2. Is that equal to 168? 12 times 14 had better equal 168 because that's what we prime factored. That's the end of section 11.2. We're beginning to work at factoring and solving quadratic equations by using the zero product property.